All right, this short video lecture goes along with page 5 in your notes, and it's about combining vectors graphically. So if we just take a step back for a second, we discussed already when we make measurements in physics, we quantify those measurements as either being scalar quantities or vector quantities. A scalar quantity is something like mass. Mass is a scalar quantity, time is a scalar quantity, speed is a scalar quantity. But let's say, for example, we'd want to add or subtract scalar quantities. For example, if I just use mass as my example, if I have something that has a 2 kilogram mass and then I have something else that's a 3 kilogram mass, there's no real direction associated with this. And I would just simply add those two numbers together and get 5 kilograms. It's easy, pretty straightforward. Vectors addition or vector subtraction is not as simple because you're not just adding the magnitudes together, you also have to consider the direction of the vector when you're adding and subtracting vectors. And that's what we're going to be looking at. So we will looking at combining vectors two ways. The first way is graphically, which is just looking at a visual picture, and then we'll take it a little bit more mathematically, and that'll involve a little bit of right angle trigonometry. Of adding vectors together first before we get into a lot more mathematical deep. So notice in the diagram here I have three vectors A, B, and C. I just have them all starting at the origin, and we're going to go through a series of adding two vectors together, subtracting, and then adding all three vectors together. So first starting off with the addition. So not only do we look at the magnitudes, and we could certainly figure out the hypotenuse of this triangle by doing a little Pythagorean theorem, but we're going to look at it visually, just graphically. So we're going to reconstruct vector A, and we're going to add to it with B using something called the tip-to-tail addition of vectors. So I'm going to scroll down here so I can start over. Okay, so vector A starts at the origin and it's 1, 2, 3, 4 units to the right and 3 units up. So it's going to go to there. So I'm going to draw vector A here, recreating it. And then I'm going to add to it tip to tail vector B. Now, if we go back up here, we can see vector B is 2 to the left and 1 up. So tip to tail means I start the tail of the second vector at the tip or the head of the second. So vector B is going to go 2 to the left and 1 up, and it's going to finish there. So I'm going to start here and finish there. So that's vector B. Okay, so this gives us our tip to tail addition of A plus B. Now what results, the resultant of adding A plus B together, I start the result of that where I started the first one and I draw it to where the last vector finishes. So if I want to know the result of adding A plus B together, I would start where I started the first one and finish it where I finished the last one. So this would be the result of A plus B. So the next type of vector combination that we want to look at is subtracting two vectors. So A minus B, subtracting A minus B, is something that's going to come up a lot, especially since we have just talked about this whole idea of a change in. So for example, we first started with the change in position. That change in position is really a vector subtraction of an initial minus final position. So we are going to see this change in for a lot of other physical quantities. So we need to be able to subtract vectors graphically before we get into the real mathematics of it. So the subtracting vectors is the same as adding these two vectors, except what you're going to do is instead of A minus B, you're going to do A plus the negative of B. And what is the negative of this B vector? It's just the 180-degree flip of B. So that is what negative B vector means. So we're going to do the same thing here, tip to tail addition with A minus B. So same thing. I'm going to switch back over to red again. There we go. So we had 1, 2, 3, 4 over, 3 up. 1, 2, 3. Yep, that was vector A. So I'm going to draw vector A here once again. That's my vector A. And then vector B, which before was 2 to the right and up, is now minus B is going to be along here. It's going to be 1 down and 2 to the right. So tip to tail addition, 1 down and 2 to the right. So this would be where negative B would be. So I'll draw that in, and that's minus B. such that now when I look at the result, or what happens when I take A minus vector B, I start the result where I started the first vector, so that the tail matches up with the tail of the first, and I draw the tip of it to the tip of the last vector. So this would be the result of A minus B vector. And that is how we subtract vectors. Try something on your own. I know it's very tempting just to skip this whole part, but just as a check, I'd like you to try, again, using tip to tail addition, add all three of those vectors together. So pause the video, give it a shot, and then come back and check the answer. All right, you're back. So same thing. I'm going to start with A again. And again, I'll come back to this whole thing, but it doesn't really, the adding of vectors is commutative, so it doesn't matter what order you add them in, you're still going to get the same resulting vector. So A was 4 over to the right, 1, 2, 3, 4, and 2 up. So that was vector A. There, oh, I stayed with blue. Okay, I'm staying with blue. So that's vector A, is that first one. B was 2 to the left and up 1. So there's my vector B right there. And then vector C was straight down 1, 2, 3, 4 boxes. So this was vector B. And then C was 1, 2, 3, 4 vectors straight down. So I'm kind of overlapping there a little bit. That was vector C. So now my result, which, sorry, I'm messing up my colors here. I'll just make this one purple because that's fun. My result of A plus B, I'd start where I started my first, and I finish where I finished my last one. So this vector right here would be A plus B plus C. So again, it doesn't matter where you start this or what order you are in, but you're going to result in a vector that is 1 down and 2 to the right. So that is combining vectors. All right, so we're going to revisit the Grace problem when Grace did some displacement and show you how that applies to actually looking at a change in position or displacement by taking my final minus my initial. Problem. So if you remember, Grace started here and finished here. So we drew the vector in of Grace's displacement. And I think I'll make this purple. So this represented Grace's displacement. So I want to show you how you can find the same vector, this displacement vector, as a result of subtracting the initial minus the final. So let's draw those back in just because it's going to help me. So if you remember, this was Grace's final position, and this was the position vector, again, relative to the origin of Grace's initial position. So I want to prove to you that if I take x minus x naught, these two vectors, and I get the displacement, I'm going to get a vector, again, doing this graphically, a vector that is straight up and is 1, 2, 3, 4, 5 boxes tall. So let's stick with red. I'm going to just kind of, so I don't, not drawing on top of this, I'm going to kind of shift it over here, and I'm going to make, I'll start right here as my kind of my origin place, and I'm going to do the final minus initial. So my final is 3 over, and let's make this 1, 2, 3 over and 2 up. So this would be my final right there. And then minus my initial means I need to take the 180-degree flip of that. So this initial position vector was 3 down and 3 over. So I want to go 3 up and 3 over to the left. So 1, 2, 3, 1, 2, 3, again, ending up right there. So this vector here is minus my initial. And once again, I can see that I end up with a vector that is 5 boxes tall and straight up. So again, probably a lot more work than just kind of looking at this because you could see it, but I just wanted to show you the connection between subtracting vectors and actually applying it to a physics situation where we're looking at displacement. And again, we're going to be applying this to a lot of other physical quantities. When we look at the change in velocity of an object, we'll look at change in momentum of an object, change in acceleration of an object. So there's a lot of different applications, and this is a more conceptual base of understanding it before we get into the mathematics. down here, and I've posted this link in Schoology. You'll see it's by a website called O Physics, and it's more practice with vector addition and subtraction. So if you'd like to practice with this a couple times, I highly recommend it. We are going to have a little homework quiz on this when we come back to school tomorrow. So I'm just going to give you a couple of vectors, and you'll have to subtract and add them together. So something very straightforward and simple. But if you'd like to practice this, let me see if I can switch it over. Yep, I think I can. So this is what the website would look like. And again, you can have u and v, and it wants you to draw u minus v. So you can mess around with where you think this vector is going to look like. So let's say it's maybe something like that. I'm just kind of guessing here, and I can check the answer and say, oh, it's wrong. It really is kind of 4 up and 4 over. So it looks like that. Check answer. Oh, look, I got it right. So it's just a way of kind of practicing, and then you can click new problem, and you can do u minus v again and keep going with that. So it's a great way to kind of just practice the tool, do a couple of them, make sure you understand it, and we'll do a little check-in quiz tomorrow.